Hello, algebra students, Mr. Lawrence here, and this is our quick factor check. We're doing trinomials, quadratic trinomials, when a is 1. Excuse me. Okay, now before we actually get into it, I want to review that standard form of a quadratic looks like ax squared plus bx plus c. Later on, we'll set that to 0 when we start to solve these, but for right now, we can go with ax squared plus bx plus c. All right, that's important to know. I'm going to reference that later in the video. So here we go. I'm going to do the one on the left. You can pause the video and do the one on the right. Then I'll do the one on the left. You can pause the video and do the one on the right. Okay, so here we go. So remember, for a trinomial where a is 1, see a is 1 here, right? I'm going to ask myself, I need two factors of 36 that add, this is adding, right, to get 13. Now, if you're good with your factors, you can do this in your head. I've already factored it. I already know the answer. But if you're stuck, and don't just run to this, start thinking about factors. Okay, you're honor students. You need to be thinking about them. 3 times 12. 4 times 9, 5 doesn't go in, and 6 times 6. So I need two factors of 36 that add to be 13. Well, that would be a positive 4 and a positive 9, right? So this is going to factor as x plus 4 as a quantity times the quantity of x plus 9. And bam, I'm done. One thing I want to point out to you, that this plus sign here shows up in both quantities. Okay, I knew it was going to be the same sign because I was adding, and I knew it was going to be positive because the b term is plus or positive. All right, go ahead and pause the video and give this one a shot. If you're still watching, I assume you've tried it. Here's my thinking. I need two factors of 48 that add to get negative 16. Well, I know that a negative 4 minus 12 is negative 16, and 4 times 12 is 48. See, I didn't even have to list all the factors if I learned them. So I'm going to have an x minus 4 and an x minus 12. And there you go. I'm done. Now I can double distribute to check my work. I'm going to leave that up to you. All right. Here's 2 with subtraction. I'll do the first one. You do the second one. All right. On this one, I need two factors of 72 that subtract, because the 72 is negative, to get negative 21. Well, all right, I guess I could go 1 and 72 and 2 and 36. This gets kind of tedious, though. 3, does 3 go in? Yeah, it sure does. Let's see. 3 goes into 75 25 times. 72 is 3 less than 75, so it must be 24. Ooh, wait. What is 3 minus 24? Negative 21, isn't it? So I'm not going to waste my time listing all the factors. I've found the pair that I need. So I'm going to have an x in each, leading off each quantity, right? And the subtraction problem was 3 minus 24. So I'm going to have a positive 3 minus a 24. And bam, I'm done. Pretty easy stuff. Okay, go ahead and pause the video, see if you can do this one. If you're still watching, you need, and you haven't tried it yet, pause the video. If you're watching now, I'm assuming that you've already tried it. So I need two factors of 12 that subtract to get positive 4. How about a 6 minus a 2? How about that? So I'm going to have a quantity of x plus 6 and an x minus the 2. Now, do you notice in these, there's one of each sign? See that? There's a plus and a minus. And over here, there's a plus and a minus. Okay? So the 72 is negative. I get one of each sign. The larger number gets B's sign. Yeah, do you notice that? The 24 got the B sign. Okay, over here, 6 got the B sign. Okay. All right, now before I wrap this up, I want to refresh your memory on how can you tell when polynomials are prime. Well, you check the discriminant. What's the discriminant, you say? Well, it's b squared minus 4ac. Remember, we said standard form was ax squared plus bx plus c, right? And let's say you're asked to factor x squared plus 6x plus 9. Now this is an easy factor. It really is. You guys should recognize a perfect square trinomial. But let's say you're having a mental blank and you can't see it. So you can check the discriminant. So the first thing I'm going to do is list A, B, C. Easy as 1, 6, 9. Okay. Then I'm going to do B squared minus 4 times A times C. And so that'll be 36 minus 36, which is 0. Okay. If this B squared minus 4AC equals a perfect square, which 0 is, 0 times 0 is 0, then the expression is factorable. So yeah, this one was factorable. If we have a trinomial, quadratic trinomial that looks like this, let's see here, x squared plus 7x plus 2. You're going to have a hard time factoring this one. So you're in the test, you're having a hard time factoring. Let's check the discriminant. A, B, C. Easy as 1, 7, 2. So I do B squared minus 4 AC. So I'm going to get 49 minus 8, which equals 41. Is 41 a perfect square? No, it is not. Therefore, this is prime. So when you do the discriminant, sounds like a dance, when you do the discriminant, you need to be able, or you need to get a perfect square. If you get a perfect square, it's factorable. You know, 0, 1, 4, 9, 16, 25, 36, hike. Okay, so know your perfect squares. That'll make your life a whole lot easier. All right, that's it for the quick check video. Mr. Lawrence signing off. Have a good night, everybody.